Hi everyone, welcome to our video on integration by parts for definite integrals. Now, when it's definite integrals, oops, it's kind of just crossed it out almost. Let me do it in black ink. So definite integrals, it's usually best to just say, hey, let's just highlight these and say, hey, don't forget about these. But to really, so we're going to set this equal, and we're going to come back up to it. Okay, so I'm going to just do a big line to say, hey, I'm going to come back up to it. But it's usually best to just do it without them first, and then once we do this, we'll use this answer to help us with this definite integral. Okay, so it's usually best to just do as indefinite integral. That's our first step, and then step 2, we'll use this answer to come back to the definite integral. Okay, so with this, so this is really just now an indefinite integral type problem. And with that, when you see ln of x, it's typically best to let u equal that ln of x. Now, it is squared, so you might say, hey, should I just do this ln of x? Well, if I do this as ln of x, I'm actually would be missing parts of it off. So I do want to include the square with it as our u. So any ln of x to any power, you want to keep all of that as your u expression. So whenever you have ln of x, it's the whole ln portion. And then with this, you could do the derivative. So the du would be 2 ln of x. So that's the power rule. And then times the derivative of this inside, which would be just an x down below. And then dx is still attached. Okay, so that's the u and that's the du. And then our dv... Our dv is the leftover part. Well, I took everything except the dx, so that means that's it. And then remember, that's really 1 in front with the dx. So for v, it is just x. So it's really that 1. You don't need to put that 1 there, but that's it. Okay, so this is my kind of table scenario that lets us now do this integral. And I usually just show it in colors. So the formula would tell us to take this top one and multiply diagonally to there. And I'm going to put the x first, though. So let's do x, ln of x getting squared. And then it's always minus the integral of these right across from each other. Okay, and again, I usually put the one that has less going on first. So we have x, and then 2 ln of x over x dx. And then now it's simplify. Well, notice here, x cancels with x in the red. And so let's rewrite it. Let's put it over here, though, now. So I've got x ln of x getting squared minus the integral of just 2 ln of x dx. So it looks like that. Okay, and then now I have to do this integral. Well, this also requires integration by parts because the regular u substitution would not work. So that means I'm just going to set up another table. Well, again, the ln portion must be the u, so it's u is ln of x, which means my du is instantly 1 over x dx. And then my dv is the leftover. Well, I guess I have that 2 there, so let's do the 2, and then the dx is the leftover. And then from here, we could do its antiderivative pretty quickly, just attach an x to that 2. Okay, so this is the second part of integration by parts for this problem. And then, well, it still follows the same strategy. ln of x multiplies the 2x there, because those go diagonal. Okay, so let's set it up. So the first term is just the same. X ln of x squared. And then minus, and then here's where we have to be careful. Let me add, oop, it freaked out. Here's where we have to be careful when we do it twice. All right, so I'm going to use green here to say, hey, this whole thing will get minused. So let's put it like that. I think that should be enough space. Okay, but in this green is where I'm doing the integration by parts. So this is where the 2x times is the ln of x. So we have 2x ln of x. And then again, always minus these ones straight across. Okay, minus the integral of those, which I'm going to write as 2x times 1 over x dx. Okay, and then now let's continue simplifying. Okay, so in this red, I have this x and that x would cancel. And then let's rewrite. So we have x ln of x squared. Now the minus will distribute. So I'm just going to kind of show it in pink. Okay, so the minus will distribute. So it is minus 2x ln of x. And then this is now plus the integral of just, so the x is canceled. 2 times 1 is 2, so it's 2 dx. Okay, so that's why I put the green bracket in, because this negative will distribute. So it changes it, makes it look like this. Okay, and then now this integral we could finish off. So this becomes, so x ln of x squared minus 2x ln of x plus this integral is just 2x. And then if it's an indefinite integral, I would really have the plus c to it. So this would be the answer if those little numbers weren't there. So I highlighted those, and we just have to make sure, hey, come back and make sure we finish it. Okay, but what I really have at this point is just this is that I'm going to use. We'll put it in blue, back to the start, and then I'm going to put those numbers in. Okay, so it is x ln of x squared minus 2x ln of x plus 2x. And then I don't need the plus c because it's a definite integral, but I need my vertical bar 1 and 2. Okay, and then now those are going to go in. Let's do it. Let's do the top one in green. So this becomes 2 ln of 2 squared minus 2 times 2 ln of 2, and then plus 2 times 2, and then we'll put this one in red in. Now I'm kind of out of room. I'm going to circle it, but let's do minus parentheses. Now I'm gonna plug this in mentally. Ln of 1 is 0, so that means this is 0. Ln of 1 is also 0. So I'm going to just abbreviate since I'm running out of room. I'm going to show it as 0 minus 0 for those two terms, and then plus 2 times 1. So let's just do plus 2 like that. Okay, so I did a little abbreviation with the red, but everything else is ready. Now, because these ln of 2's are in, I'm kind of assuming they would want a decimal answer. So that means I'm going to go to my scientific calculator. And let's make it so we can see it all. Okay, so, and now I'm just going to type in everything in that green portion. Okay, so we have 2, and then be careful with those parentheses. Okay, so it is, let's go ahead and put the first one there, 2. So 2 parentheses ln of 2 squared, like that, and then minus 2 times 2 ln of 2, and it looks like I forgot one parentheses. Let me put it on there to make it match exactly. There we go. And then plus 2 times 2. Oops. Plus 2 times 2 just to make it look exactly, and then parentheses, and there we go. And so it's that as the decimal minus this in the red, which would be just minus 2. So let's take that answer right there. I'm going to copy, paste, and just minus 2 to get the final official answer. To 3 decimals, it's 0.1833. Okay, so that's it. So 0.1833 is our answer for this problem. So this all became, what did I say? 1883. 18. I can't read sometimes. Okay, so to 4 decimals, 0.1883. Okay, so that's our strategy. So notice with definite integrals, it's really just, hey, do it like a regular integral, but then come back and plug in those numbers eventually. Okay, so let's do that one more time with number 2 here, where we have an e to the x scenario. All right, and it's probably best, so they might not set things up correctly for us right away. With integration by parts, let me go ahead and put a line to block that off. Okay, so let's add a note. Integration by parts is for products. Okay, so with this right here, it's currently a quotient. So we need to convert this. And it's pretty easy. That all we have to do is just move that e to the x up with a negative power. So we want to see it as 0 to 1, 10x plus 3 in parentheses, and then e to the negative x like that. And then we'll attach the dx to the side. Okay, so we want to make it so it's a product. And then just like the first one, let's just put equals. And then we'll come back to it. I'm going to highlight these and say, hey, those numbers there are important. But let's save some space. And then let's just do the definite integral. So what I really want, I think let's give myself a little bit more room actually for this top portion. And what I really want to do is just do the 10x plus 3 times e to the negative x dx like that. Okay, so and now that we have this set up, we want to set up our integration by parts table, because regular u substitution is not going to work in this problem. So let's set it up where we have our u. Now the u is usually the algebraic expression in these, so it would be the 10x plus 3, and then our du we can instantly find would be just 10 dx, and then the dv part is usually the e. So we have e to the negative x, and then dx there attached. Okay, so we have our u and then our dv. And then with this, well, the integral is negative e to the negative x. All right, there it is. All right, so this is our table that sets it up. And then from here, we could do our integration by parts formula, which tells you take this and multiply them. Okay, so we'll have that as 10x plus 3 times negative e to the negative x, and then always minus those ones straight across with the integral in front first. Okay, so let's write it as, I'm going to write it as negative e to the negative x and then 10 dx. Like that. Okay, and then now let's simplify. So the one in the blue looks fine. It is just 10x plus 3 times negative e to the negative x. Now the second one, let's go ahead and do the negative 10 and the negative. Let's go ahead and take that out since it's a constant anyway. So a negative and a negative would become positive. Oops. And then I want to take the 10 out. Let's just put that in the front. And then we have our integral of e to the negative x dx. And then that integral is easy to do now. So let's finish it off. So this is 10x plus 3 times negative e to the negative x plus 10. And this is negative e to the negative x, just like that. And again, if it was an indefinite integral, we would have plus c at the end. But we're going to come back to it and plug it all in without it because we're going to plug numbers in. Okay, and then also, let's go ahead and do one thing as simplifying. This second term can be simplified. Let's write it as 10x plus 3 times negative e to the negative x, and then plus a minus would be minus, or plus a negative is minus 10e to the negative x, like that. And then still, if it was indefinite, this would be the answer. But all I really want is just this to plug back in to our definite integral. Okay, so definite integrals, they're a little worse in these problems because, well, if it is indefinite, we're done. But now I have to go back and plug it in. Well, let's take what I underlined in blue there and rewrite it as 10x plus 3 times negative e to the negative x minus 10 e to the negative x. Let's put all that in parentheses, and let's put our bounds now 0 to 1. And then now is where we would plug these in. Let's use green for the top. So 1's going into all the x's. So it becomes 10 times 1 plus 3 and then negative e to the negative 1 minus 10 e to the negative 1. So there's that one. And then the 0 is going to go in, minus 10 times 0 plus 3 times negative e to the negative 0 minus 10 times e to the negative 0. Okay, so I just copied exactly. And then again, it's probably a calculator at this point with those e expressions. Okay, so I've got my Desmos again. Let's scroll so we can see it all. Okay, so that's good. Okay, so I'm going to copy this, the exact same thing that I see in the green. Okay, so parentheses 10 times 1 plus 3 parentheses, and then negative e to the negative 1 parentheses, that looks good, and then minus 10 e to the negative 1. I think that looks good. Okay, so it looks like that. And then let's do it all in one big step. So I'm going to copy, minus, paste, and let's change those ones to zeros. So 0, and then this one is 0. And negative 0 we don't need. We would just write, it works the same, but I'm just going to write 0 at that point, like that. Okay, and it looks like that's our answer. 4.539 to 3 decimals. 5. Okay, so that's it. So we are done. Okay, so I just copied, and so that's what's again nice about the scientific one. Just copy it exactly as you see it. If you use those parentheses well, it will work and do everything for you. All right, and that's how I'm doing it. And then I've got the final answer was 0.4. Oh, let's just put it in black ink. 4.539 to 3 decimals. Okay, so that's it. Okay, so that's it. So our definite integrals with integration by parts is really just an indefinite integral problem first, and then come back and plug stuff in. All right, so it's coming back to the start. And then also notice with these problems, you do need products. So if they give you a quotient and regular use substitution is getting you nowhere, well then try rewriting it as a product so that you could do integration by parts. All right, that's it. All right, so if you have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.